Hello everyone, welcome back to grade 10 Applied Math here with Mr. Stone. So today we're going to keep talking about trigonometry. We're just going to extend everything we did and now actually solve some problems. So previously we'd figured out how can we solve, what trigonometric ratios we can use, and then we stopped. We didn't actually finish the problem. So now we're going to go a little bit further and we're going to actually do a little bit of algebra and solve the problems themselves. Okay, so just a quick recap. Remember, if you have a right angle triangle like this one, so right angle triangle, that means that there's a hypotenuse, a longest side that's opposite, farthest away from the right angle here, the right angle triangle, and the two other sides, so this one's again, the longest side we labeled the hypotenuse, and then we have an adjacent and an opposite that are relative to the angle we're looking at. So in this case, let's say we're using A as our reference point. The side opposite A here, this is the opposite side, we'll label it OPP. It's side BC or side little a. It's farthest away from A, and then adjacent is the one closest. And then because of similar triangles, when we can scale triangles bigger or smaller and the ratios of their sides stay the same, we're able to come up with or give names to some of these ratios, some of these important ratios. For example, the opposite, the angle, the side farthest away from the unknown angle or the known angle, whatever, the angle we care about, divided by the hypotenuse is this ratio, is this number sine A. And we can do the same thing for the adjacent divided by the hypotenuse. That was cosine A, and then opposite divided by adjacent we called tan A, tangent of the angle A. And remember, these are just numbers. I can plug them in, plug a number in for my angle, like, whatever, 40 degrees. I can plug that in my calculator and it'll give me a number. And that number represents the ratio of those sides. And there was a nice way that we could memorize these things called Sohcahtoa. And it's a nice little mnemonic that helps us remember these three ratios. So sine, the opposite of hypotenuse. So we say so, S-O-H, ka, cosine is adjacent over hypotenuse, and toa, tan, is opposite over adjacent. Sohcahtoa. Okay? So let's try a problem. So let's say I have this triangle and it's asking me to find out how long this side here, x. All we know about the triangle in terms of lengths is the length of the hypotenuse. We know that it's 16. But we also know the angle over here is 25. So how can I use this information, just knowing an angle and a side, to come up with a second side? So first thing we have to do is using our appropriate labels, label it. So remember, 25 is the angle that we're using to look with. So using that information about, that 25 is the angle I'm looking, it's where I'm looking from, right? This is my reference point. So hypotenuse, that's easy. It's the farthest one. The longest side. Opposite is going to be the angle, the length farthest away, and adjacent is going to be the closest. And now when I look at this, notice that the adjacent has nothing to do with the problem. There's no length given there. We don't know anything about that. All we care about are opposite and hypotenuse. Hypotenuse we know, and opposite we don't know. But we still care about them, right? We have opposite and hypotenuse as the sides that matter to the problem. So I look at my Sohcahtoa and I think, okay, so opposite, so that's O. So it can either be So or Toa, and then I have H, so it has to be sine. And the ratio that I have to work with for this problem is going to be the sine of my angle. So sine of my angle, here let's call it theta. It's just a funny Greek letter. It means Q in Greek. Mathematicians really like to use it as a symbol for an angle. It's basically just a circle with a line through it. Theta. T-H-E-T-A. It's called theta. So the sine of that angle is opposite over hypotenuse. So now what do I know? I can replace some of these numbers, right? I can replace my angle with 25, and I can replace the hypotenuse with 16. I've done a quick little substitution here, right? My angle is 25, it's gone into there, and my 16 has gone into here. My unknown is still there as x. I have one unknown, I have an equation. I can solve it, right? So what do I do here to solve? I want to get x by itself. So x right now is divided by 16. So let's multiply both sides of my equation by 16. What happens now then is 16s are going to cancel. And I'll end up with an expression here that x is equal to 16 multiplied by sine 25. And there I just have to plug that into my calculator. You got to be a little bit careful when you're doing this. Some calculators work in different ways. Sometimes you have to press the sign before, like an iPhone or something like that. You have to press, like probably just type in 25 sine. I don't know exactly. I'm sorry. You'll have to experiment, but the final answer here should be 6.7. Sorry, 6.76. Okay, and what's nice about trig problems or any geometry problem really is you can look at your picture and see if it makes sense. So right now we know that the longest side is 16, and I got an answer of about 7, right, which is about less than half of 16. Is the length that I'm looking for here x? Is it less than half of 16? 16's here. There's about half. There's less than half. That looks about the same length, doesn't it? So it works out. If I got a number that was more like 13 or something, I know I did something wrong because I probably got this length here, right? This looks closer to, this was up here, it'd be like 14 or something like that. And if I got a number that was bigger than 16, right, I know automatically that that's wrong because I know that the hypotenuse is 16. Hypotenuse is defined to be the longest side. If I got an answer that is longer than 16, that means that 16 is not the hypotenuse, and I've done something wrong somewhere. Okay, so when you're done, look at your answer and think, okay, does it fit in my picture? Does it make sense in my picture? Okay, all right, let's try another one. So let's see what I have here now. I have an angle. I have the longest side being unknown, so the hypotenuse is now unknown. And so what else do I have? I have the adjacent, right? Because 65, sorry, is closest to 35. And again, what I look at is think, okay, so I know I care about the hypotenuse, right? It's unknown. I care about the adjacent. It's a known. The opposite is nothing. It doesn't matter at all. So this is A, this is H. I look here. Oh, this Ka has A and H in it. So that represents the ratio of cosine. So the cosine of my angle is adjacent over hypotenuse. And that's the hard work done for the problem. The rest is just algebra, right? So now we can substitute in our numbers. So my 35 goes here, my 65 goes into the other one, right? I'll just do a little substitution. Now we have a problem. This is going to be trickier to solve, right? Because the unknown is on the bottom. And I'm just going to give you a little math trick here. If ever you're in a situation like this where the unknown is in the denominator, you have something like this. We have a term equals something we know divided by something we don't know. If you want to solve that, very easy. Just rewrite it with the number over here and the denominator flip. So rewrite it like this. So it's going to be x. X was below, so now it's going to be over by itself. And the thing by itself is going to be down below in the denominator. So x is going to be 65 divided by cos 35. There's a little math trick. Actually, what we're having to do is we have to multiply both sides by x and then divide both sides by cosine of 35. But really, this is a nice little math trick I always use, right, to solve if I have an unknown on the board. Now I can just plug it in my calculator, and I end up with a length of about 80, 79.3. And again, look at our picture. Does it make sense? So let's see. So this is 65. Can this be 79? Does that make sense? It's longer than 65. Does that make sense? Yes, because it is my my hypotenuse, right? It has to be longer. And 60. Oh, the diagram's to scale. So that angle is probably much larger than 35. So these pictures aren't always drawn to scale, but it's still, we can look at it and get a sense of, does it make sense, right? It's longer than 65. So we're good to go. Okay. All right. One more that's slightly different. You'll see why. Determine the unknown angle. Previously, we've been looking at unknown lengths, but now we're going to actually find out an angle using trig. So again, we're going to do our labeling. Okay, so we have opposite and adjacent. I have an adjacent side I know and an opposite side I know. So hypotenuse doesn't matter. And the only one that doesn't have an h in it is TOA. The ratio I care about in this case is going to be tan. So the tan of my angle is going to be opposite over adjacent. And if I plug in my numbers, the opposite is 35 and the adjacent is 20, I get this ratio. I can put this in my calculator, right? I can get that this is going to equal 1.7. Right? 34 divided by 20 is 1.7. Now, this is a bit strange here. So that's saying that if I take an angle, a number, let's say, I don't know what this looks like, 30, 40, something like that degrees, and I put it in my calculator and I hit the tan button, it's going to give me 1.7. So it's giving me the answer. So I have to do it backwards. I have to find a way that can calculate an angle given the tan. And your calculator does that by doing what we call the inverse tan. You do that by either you're pressing on your calculator. There could be like a second button or an INV, something like that. Or you can look for above your tan button should be like a tan minus 1. If you have like a physical calculator, not an iPad, iPhone calculator, you just have to go to the second function. So you're going to hit second function tan, and it comes up with this thing called inverse tan. So we're going to take the inverse tan, or tan minus 1, so this is called here, of 1.7. And it's going to give us an answer of 60 degrees-ish, 59.9 degrees. Okay? So that's a little bit tricky. This we have to get with either like a second function or an INV button somewhere on your calculator, something like that. Some button like that changes your tan, sine, and cos buttons into that, or on like a physical calculator. I do. Look. So here. Will this work? No, it's backwards. Okay, but on this, above it, it says sine minus 1, and then there's a little shift button. Now, it could also be a shift, something like that. Okay, and again, I'm going to stop for a second. Doesn't make sense. Does my angle look like 60 degrees? Yeah, pretty good. If it looked like, if it gave me an answer that was, an easy mistake you could have made here is you could have had this upside down. When you could have put 20 divided by 34, and that would have given you an answer of 30 degrees. And automatically you would see that that is this answer, not the one we want. Okay, so with these problems, again, always look at the answer that you got, see if it makes sense. All right, and this does, so good to go. All right, so that's how we solve problems with trig. Let's try now to apply this to some real world problems. Okay, so that's the whole point of trigonometry, is trying to figure out things in real life that actually matter. Like here, for example, we have a 2-meter ladder. Okay, the ladder itself measures 2 meters long. I'm going to put it next to a wall, climb up to do something, and the angle that the ladder makes with the wall is 80 degrees. Question is, how far from the bottom of the ladder is the wall? Okay, how far is the bottom of the ladder from the wall? So what that means, in my picture here, so I know this is 2 meters and that angle is 80. I don't see any triangles just yet, so let's make a triangle. So this blue triangle is the triangle we want to know, and it's going to be, it's a right angle triangle, so we can use our Sohcahtoa. So now that we have our triangle, let's do our labeling. right? We know that we have our unknown that we want is x down here. And we know that the longest side of our triangle is the 2 meters, and that's the hypotenuse. And our unknown is going to be the adjacent. Right? It's the angle the side that's closest to our angle, 80. So which ratio has adjacent and hypotenuse? Right there. So the ratio that we care about is cosine. So I'm going to write out always do this, always make sure you always write out the ratio we care about. Okay, that's probably one of the most important parts of the problem is going through that, figuring out which ratio to use. The rest is just mechanical algebra. This is the trigonometry part here. So make sure you write that down. So let's substitute in. We know our angle is 80. We know our adjacent is our unknown, x. And we know the hypotenuse is 2 meters, right? So again, we need to solve for x in this case. So right now, x is divided by 2. We want x by itself. So let's multiply both sides by 2. Right? That'll cancel out the 2's, and we're going to be left with just x is equal to 2 times cos 80. And then plugging that into our calculator, we end up with 0.35, which really is 35 centimeters. And does that make sense given our picture here? If we have a 2-meter ladder and I put an angle of 80, does it make sense that the distance there is 35 centimeters? Yeah, that works. And of course, because this is a word problem, our last step is always a word statement. So the bottom of the ladder is, pardon me, is 0.35 meters or 35 centimeters from the wall. And we're done. Okay? Awesome. All right, one more problem. So this is an example of why trigonometry is awesome. Okay, so let's say I have this really tall tree, world's tallest tree. It's a California redwood. Okay, we want to know how tall it is, but it's impossible for me to get to the top of the tree. Okay, it's a very, very tall tree. I can, however, measure a distance from the base. I can measure 80 meters from the base of the tree with a measuring tape of some sort. Okay, or I can even just pace out, 80 meters. I can then use something to calculate angles, and I can find that the angle from where I'm standing, right, if I'm standing here, is 75 degrees all the way to the top of the tree. How tall is the tree? Okay, I've made a right angle triangle by walking away 80 meters from the tree, and I want to find out its height. It's h here. Now, what I can do is I can label this, right? That's the opposite. This is my angle, it's farthest away, so it's the opposite side. And I know my adjacent side is 80 meters. And that's the closest side to the angle of 75. And what ratio has O and A in it? Tan. So I'll write out my tan theta is equal to opposite over adjacent. I substitute in, I know that tan of, oh, right, that should be 76. That should be 76. Sorry. So the tan of 76 is h over 80. So now, how do I solve this? Multiply both sides by 80. Okay. Cancel. So I get h is equal to 80 times tan 76, and it gives me a distance of, a height of 320 meters, or more than 500 feet. It's a big tree. So therefore, that tree is 320 meters tall. Okay, wait a sec. I didn't do that. My last step. Check. Does it make sense? This is 80 meters. This is 320. Yeah, that fits the diagram. All right, we're good to go. All right, so that's how we use trigonometry. Well, really, you did all the hard work in the previous lesson, finding out what the ratios are. Using Sohcahtoa, figure out the ratios. That's the hard work in trigonometry. The rest is just algebra, substituting in and then solving. All right, so hopefully this isn't too difficult. It's pretty much what we did in I think it was Unit 2, Activity 4. But all we're doing is we're adding the little algebraic step in actually solving the problem. Okay? All right. So best of luck, and I'll be talking to you later. Take care, guys.